So in this video, I just wanted to do a little side video for unit vectors and how I was able to derive all of the unit vectors. So I guess I'll call this some like derivation of unit vector video, something like that. So let's start unit vectors. Unit vectors. And we'll start with in the 2D system. And that really helps to segue really nicely into let's make this a little darker, into the three-dimensional unit vectors. So we have our axes, y and x, and we have some point, and it is a distance s away from the origin, and this is a vector s. And so we want to describe this point. We can describe this point in Cartesian, and it would have coordinates x and y, or we can do polar, and it would have s and phi, where phi is this angle from the x-axis to s in the positive direction. And so how can we write s in terms of Cartesian, and then how can we write s in terms of s and phi? So we've already defined s as in Cartesian as some x in the x direction plus some y in the y direction. So then s simply becomes x hat plus y hat. And s is also equal to, in polar terms, s hat. And so when we're trying to rewrite s in terms of phi and s from our Cartesian, it's important to remember some trig. So I'm going to draw a triangle that we get from all of this information. We have phi, this is s, this is x, and this is y. And I still use this little handy trick, so toa, and that's just going to help me to remember our trig identities. And if we want to write x in terms of sine and cosines and that kind of stuff, we use SOHCAHTOA. So we can relate sine of phi is going to be equal to the opposite over the hypotenuse. And the opposite in this case is going to be y, and our hypotenuse is s. So we have what sine is, sine of phi. Cosine of phi is our adjacent, and in this case that is x over s. And our tangent of phi is equal to our opposite over our adjacent. And our opposite is y over x. And so from here, we have related s and y and x and s and x and y. And so now we can sort of use these to solve for these individual components which is going to be important when we're trying to write S from Cartesian to polar. And so we can solve for y, and y becomes the magnitude of S times sine phi phi. I don't know, some people say phi, some people say phi. So I might use that interchangeably. And then we can do the same thing for x. We have the magnitude of S times cosine of phi. And for tangent, I guess I can just solve for phi. And that's going to give us phi is equal to tan inverse of yx. So I hope everyone sees how I got that. I just multiply this by s and it gives me phi, and multiply cosine phi by s, and x over s by s. X out the s, and the s comes over on the side, and then I have x. And here, trig function, I can just take inverse tan, and it will give me phi. Okay, and so this information helps us when we're attempting to solve this. So now we can write this s in terms of s and phi. So we can say the magnitude of s times phi plus, oops, don't forget your x-hat because you need direction, plus magnitude of s times cosine phi y-hat. And we said that this is also equal to this. So now we have magnitude of s hat is equal to magnitude of s sine phi x hat plus magnitude of s cosine phi hat. And we can just divide out the magnitude of s. So then we're left with s hat is equal to, it's getting kind of cluttered, sine phi plus cosine phi y. And there we go. We have solved for s hat. And that's going to be extremely important when we're going to three-dimensional systems. Now what we want to do is solve for maybe Phi-Hat. And so we have our, I guess we can go back here and figure that out. How do we find Phi-Hat? So we know that S-Hat is here in the increasing positive direction. We know that Phi-Hat by definition is perpendicular to S-Hat. So I kind of do it, I don't know if it's a weird way or not, but I kind of like say S-Hat, and I say that this is Phi-Hat. And we know that this is phi. It has components cosine phi, sine phi, right? And this, it sort of has the same x, but in the opposite direction. And it has the exact same y. So if we recall, S-Hat was equal to cosine phi x-hat and plus sine phi y hat, we can just say to ourselves, well, it's this, it's S, but it's x hat. Its x hat will be in the opposite direction. So we have cosine, it has the same magnitude, which is our cosine phi, that's our magnitude, put that here, and it's in the opposite direction. So, and I'm writing this for phi hat, and then it has the exact same y component, so s phi v, my bad, x hat, and then we get that phi hat is equal to negative cosine phi x hat plus sine x hat. So there we go. We've solved for s hat and phi hat.